All right, in this project, I want to look at one of the more powerful features of generators, which is the ability to set up processing pipelines and workflows. And to set that up, I want to return to Unix for a second. One of the things that we did is we wrote a Python function that emulated the behavior of the Unix tail -f command. Just to see that, what we did is we did a tail -f, and we were watching a file as data was being written to it. This is the kind of thing that you would use, again, to watch maybe a web server log or something like that. So in this case, I'm watching stock market data. One of the more powerful features of Unix, though, is that you can set up pipes. Like you can take the output of one command and pipe it into another command. So maybe I can do something like this, where it's like I could say, I'm going to take the tail -f and I'm going to pipe it into a function that looks for just certain substrings. What's going on now is I'm following the file, but I'm only interested in those stock names, IBM, Microsoft, CAT, and AA. It turns out that I can do a similar thing to that using generators. Here's how you might go about doing that. Do an example here. So first of all, I'm going to run this little follow program that I have. The code at the top, I've got this follow function. What I'm going to do is go ahead and start this again. So I'm going to say, okay, let's follow this file, stocklog.csv. That is a generator that comes back. Keep in mind, the follow function up here is using the yield statement. That makes it one of these generator objects. If you call next on it, you're going to see it pop out lines of data. One of the things that you can do is you can take that data and start to feed it into other functions that work with the for loop. This might kind of blow your mind a little bit, but one of the things that I could do is feed this into the CSV module. This is something that we worked with earlier to parse CSV files. So what I could do is I could say, hey, oh, rows is equal to CSV reader of lines. Turns out that this rows object also knows how to do iteration. So what's happening now is the data from this follow function is going into the CSV reader and it's coming out as rows that have been split up and kind of cleaned up. And that's kind of interesting. I could then take that one step further. Maybe I could write like a grep function where you give me some stock names and some rows. And then what I'll do is I'll do a little for loop. Like I'll say for row in rows, if row 0 is in names, yield row. What's happening here is I have a function that's pulling in data, looking for something, and then emitting something that is a match. So then what I could do here is I could say, matching is equal to grep, where I give it a set of stock names like IBM, Microsoft, CAT, and AA. I think that's what I used earlier. On rows, this is also a generator object. If I start calling next on it, you'll start seeing it emitting rows for just those stocks. I've essentially done exactly the same thing that I did in that Unix example. It's the follow function is feeding that CSV reader that I've set up here, and then that is feeding this grep function, and we're getting like a bunch of things kind of popping out. You can extend this idea even further and maybe do things like type conversion on these fields. This is a more advanced thing. Well, let's make a little list here, types. It looks like we have a string, a float. What I'm doing is looking at the data and matching up types. I'm just going straight across. We have a string, we have a float, we have a string, and then it looks like a bunch of floats. After that, I could do something like this. I could say, well, the converted values is equal to a generator expression where I do type conversion. I have a generator object. If you call next on that, now what you're getting is you're getting a bunch of data that has been converted. You're seeing it's no longer as strings. I could get the negative change. I could say, well, these are all the rows in converted if row 4 is less than 0. That's that idea. I forgot a for statement in there. Now you have a generator which is only producing negative change events on it, but only for those stocks that are in that list. This is a very powerful idea that's taking place here. I mean, essentially what you can start doing are writing programs that use this technique to kind of set up little like little workflow things, looking for negative change, looking for, doing type conversion, doing CSV parsing, and so forth. You might be able to package all these ideas up, into a function. Like up here, I could say, let's make a function parse stock data, where you give me some lines. I don't even really care where those lines are coming from. But what I'm going to do is just set up like a pipeline. I'll say rows is equal to CSV reader of lines. And then maybe I'll do the types thing. Like the type was a string, a float, string, float, int, I believe. Okay, so we had something like that. I could say converted is equal to that type conversion trig. Maybe I return that back. And then we start writing like little workflows on that. Maybe you say lines is equal to follow data stock log CSV, and then rows is equal to parse stock data lines. And then maybe negative change is equal to, row for row and rows if row 4 is less than 0. And then you start writing for loops on it. It's kind of an amazing sort of thing that you can do here. This is only giving a small taste of what's possible. This idea of workflows actually applies to a wide range of kind of problems involving data processing and other tasks. Got a little bug in my string formatting there, but let's modify it and see if it works here. Okay, so that's a little bit more of an advanced use of generators, is that essentially you can customize for loop, but then you can get into these like workflows and pipelines. Very interesting kind of way to program and structure data processing tasks.